This is Trekzone's Talkin Science.
Welcome to Talkin Science, the bite-sized version. Coming up today, a roundup of the latest science and space headlines over the past week and a bit, continuing the on-location in Melbourne thing. From Martian core to methane-producing microbes, a nesting binary, and using tree rings to learn about radiation storms. Here are the 7 stories I reckon we need to know about. The alignment between galaxy spins and large-scale structure of the universe reveals the processes by which different components of galaxies form. An observational study recently published in Monthly Notices of the Royal Astronomical Society found that the size of the galaxy's bulges changes how their spins align with the surrounding structure. The large-scale structure of the universe is traced by the distribution of galaxies, and this cosmic web consists of giant filamentary structures linking massive clusters of galaxies. Like our own Milky Way, most galaxies have 2 components: an extended disk in which new stars form from gas, and a central bulge of mostly older stars that grows over time. Well, early Mars could have been home to some methane-producing microbes, much like early Earth was, according to new computer simulations created by international researchers. The potential habitability of early Mars, that's more than 3.7 billion years ago, mind you, has been extensively debated. Evidence suggests that the red planet hosted, at least for part of its history, potentially favourable conditions for the development of life. The likelihood of such a scenario, however, has rarely been established quantitatively. The prediction from the research team says that this ecosystem would have triggered a feedback event with the climate on Mars, cooling it globally by up to 40 degrees Kelvin and creating less habitable conditions closer to the surface. This would have forced the microbes to move progressively deeper within the planet's crust. Looking forward, the authors identified 3 sites: Hellas Planitia, Isidis Planitia, and Jezero Crater, currently home to the Perseverance rover, as the best places to look for signs of this early methanogenic life near the surface of Mars. Curtin University researchers have helped discover the largest fresh meteorite impact craters on Mars since NASA's reconnaissance orbiter began scouring the planet for them 16 years ago. As the only Australian representatives on a NASA-led international research team, the 2 Curtin scientists helped make the rare discovery of 2 impact craters larger than 130 metres in diameter, which were formed on Mars in the second half of 2021. Research co-author Associate Professor Katarina Milcevic from Curtin's Space Science and Technology Centre and the School of Earth and Planetary Sciences said the discovery of the craters was made through the use of both NASA's imaging technology and seismometers. Well, speaking of seismometers, seismologists at the Australian National University have developed a new method to scan deep interiors of planets in our solar system to confirm whether they have a core at the heart of their existence. The scanning method, which is similar to an ultrasound, requires only a single seismometer on a planet's surface in order to work. It can also be used to confirm the size of a planet's core. Using the ANU model to scan the entirety of Mars's interior, the researchers determined the red planet has a large core at its centre, a theory first confirmed by a team of scientists in 2021. Confirming the existence of a planetary core, which the researchers refer to as the engine room of all planets, can help scientists learn more about a planet's past and evolution. It can also help scientists determine at what point in a planet's history a magnetic field formed and ceased to exist. Using a single seismometer on Mars's surface, the ANU team measured specific types of seismic waves. These seismic waves were triggered by Mars quakes, and they give off a spectrum of signals, or echoes, that change over time as they reverberate throughout the Martian interior. More James Webb news, and another image that's been released, this one of distant star WR140 showing concentric rings, geometric ripples even. That was captured by the telescope back in July, and it's been baffling scientists worldwide until now. In 2 companion papers, both published today in Nature and Nature Astronomy, 2 Australian astronomers explained that the 17 concentric rings seen girdling the star are actually a series of mammoth dust shells created by the cyclic interaction between a pair of hot stars, one of them a dying Wolf Rayet, locked together in a tight orbit. The WR140 binary is comprised of a huge Wolf Rayet star and an even bigger blue supergiant star, gravitationally bound in an 8-year orbit. And while all stars generate stellar winds, those from the Wolf-Rayet stars can be more likened to a stellar hurricane. Elements such as carbon in the wind condense out as soot, which remains hot enough to glow bright in the infrared. Like smoke captured by wind, the dust clouds give telescopes something to observe following the flow. A University of Queensland study has shed new light on an unpredictable and potentially devastating astrophysical event. A team led by Dr. Benjamin Pope from UQ's School of Mathematics and Physics applied cutting-edge statistics to data from millennia-old trees to find out more about radiation storms. These huge bursts of cosmic radiation, known as Miyake events, have occurred approximately once every 1,000 years, but what causes them is unclear, Dr. Pope said. Enter the Humble Tree Ring. Using software to analyse thousands of pieces of data and tree rings, the team are able to identify carbon-14, the element produced by radiation as it enters the atmosphere. Long thought to be caused by solar flares, Pope's team's research challenges this, indicating that it was more likely an astrophysical storm that potentially lasted years and not related to our star's sunspot activity. Researchers have found that NASA's satellite orbiting Carbon Observatory 2 and the instrument OCO-3 on the International Space Station were able to track the carbon dioxide plumes above Europe's biggest coal-fired power station between 2017 and 2022. Countries that have signed up to the 2015 Paris Agreement have committed themselves to keep the rise in average global temperature well below 2 degrees Celsius. Every 5 years, they are to issue so-called nationally determined contributions, describing their actions to reduce greenhouse gas emissions and adapt to climate change impacts. Countries will thus need to track their carbon emissions, not only at a national level, but also at the scale of individual super emitters, such as power plants, megacities, refineries, and giant factories. And scientists have shown that the tools they need are already at their fingertips with these instruments and others that will be coming online in years to come. Well, Dr. Brad's here on the first Tuesday of every month, and I've got your bite-sized wrap on the other Tuesdays, mostly. From Melbourne, from wherever I happen to be, thanks to Trekzone Media taking off around this great country of ours. Don't forget Trekzone membership. It's available via the join button under every video on YouTube. You can also click thanks for a one-time contribution via the YouTube system. Or if you don't want to do that, jump onto the Trekzone, the trek.zone/PayPal to contribute directly. It's all going into the 20th anniversary budget for next year, a massive gala event. And even before that as well, the 1,000th episode of Trekzone coming up around the start of December. So be on the lookout for all of that. Members are getting first play access to the podcast and also behind the scenes goss on what is coming up for the 1,000th and the 20th anniversary celebrations as well. Looking forward to all of that. For now though, I am Matt Miller in Melbourne. I'll catch you in the comments.